Hi, I'm Mark Christian. I am the Global Director of Immersive Learning at Pearson Education. Pearson is the largest education company in the world. We operate pretty much in every country you could think of. We have a big presence in Europe, and we're based in London. Today I'm going to talk a little bit about different technologies that we've used in the classroom. I'm going to focus on classroom uses of this and pedagogical uses of this. So I'll talk about the good and the bad, what we've learned works, what we know doesn't work, or we have data that doesn't work. My team and I build AR and VR products and MR products for Pearson globally. We have, we work in 360, in proper virtual reality, in mobile AR and mixed reality. And I'll show you some examples of the work that we've done and what works, and share with you some experiences of what doesn't. We're reaching hundreds of thousands of students, soon to be millions of students next year in our courseware, so in our supplemental products where we build content that sits inside of Pearson courseware. We are in the hundreds of thousands, soon to be thousands, and we're in the tens of thousands when we talk about our standalone products, which are simulation-based products using VR and MR. We try to build device-agnostic products as much as we can. We all know that's probably not always possible, and you'll see some examples of that. And we look for quality over quantity. Most of the projects that come to us as ideas inside Pearson are actually rejected because we don't believe that AR or VR lends any value to them. So we focus on what actually we know works rather than what looks cool or what ideas are out there that we know don't work. So what works and what doesn't in the classroom? I'm going to start by showing you some of the things that don't work in the classroom, or at least not so far. And here's an example. What I mean by that is strapping students into VR headsets and sitting them in a classroom and expecting them to learn something. It looks great. It looks like the students are having fun. The educational value of this is pretty low, and where there is an educational value, and I'm not saying that the app itself wasn't useful and the students didn't enjoy it. The problem is that this is not how we teach. This is not how teachers teach in the classroom. And it might be a great one-off case study, but the chances of a teacher going back to this and using this as a teaching mechanism are pretty slim. And some of us wish that wasn't the case, but it is. Likewise in training. Sticking a whole training group, cohort, into a training session and expecting them to learn something could work. Doesn't work in terms of pedagogy. It doesn't work in terms of the way that we teach and interact with each other. In fact, when I show these pictures to educators, often we get cries of, "This is a dystopian future," and nobody wants to be involved with it. So if your idea is to sit students down in a virtual reality headset, you might want to rethink that and come up with different solutions on how to get students to engage. Now, what seems to work a bit is this is Google Cardboard, right? This is Expeditions. Students using drop-in, drop-out experiences where it adds to the pedagogical tools that a teacher's using in the classroom. That works, and it has some compelling use cases. The data is probably not there yet in terms of its efficacy, but it is something that we've seen that teachers will go back to and reuse. And really, one of the biggest indicators of how it's being used in a classroom is if teachers go back and use it again past the initial use case. So barriers. The key barriers that we have in education and in using this technology in the classroom, and these are pretty clear across lots of different technologies, of course, are the cost benefit for assessment and then research and evidence. And when I mean the cost side of things, I mean device costs. And research, we just don't have the research yet in many cases to justify massive expense and investment into the technologies. So how do we overcome these barriers? Why do we exist? Why does my team keep building content for Pearson? And that's what I'm going to spend most of the time on today. So we focus on what we know today that works, and that includes assessment. It includes simulation, homework, and collaboration in the classroom. And I'll give examples of all of this and talk a little bit about them. We'll start with assessment. So what we mean by assessment is students doing something and getting graded on that. Virtual reality does lend itself well to this type of experience. And an example of that, this is a very early example we did in 360. This was a health and safety assessment where the student literally had to look around an exceptionally unsafe work environment, which you'll see here, and identify all the hazards. This is an actual ice factory for ice sculptures in London. And the student's job is to identify the hazards. Now, this led to a qualification, a health and safety qualification, and is still widely used today, even though the product itself now is about 5 years old. One of the first things we ever did, and it works great. It is a better solution than what exists today, which was most students took a worksheet back to their office and did an assessment on their desk. We actually brought students into an unsafe environment and had them identify all the hazards. Another example of assessment is in this. Again, students doing something. This is crane signaling app. So students are signaling the crane operator in this virtual world on how to do something. They are getting a qualification at the end, and there are thousands of students just in the UK alone that actually have to do this every 2 years to get recertified. So again, the assessments that we talk about are about doing, and the students in a very practical way doing something that is impractical in the classroom. Simulation. Now this is probably the thing that's nearest and dearest to my heart and the thing that you'll see a lot of all over the world. Now in simulation, this is our HoloPatient product. We've been focusing a lot on healthcare, and we use volumetric video here, and what we've done is we brought in actual unhealthy, unwell patients, many of these scenarios. We film the patient, and we allow students, nursing students, medical students, to have experiences with these patients that they otherwise wouldn't have. And it improves clinical outcomes, and it improves the ability of students to have exposure to experiences and to patients that they otherwise wouldn't have and need to have exposure to. And this product is on the market. We are building many more experiences to go along with this. But this is volumetric video using Microsoft's holographic capture technology. Another example of simulation that we've worked on, and we did this in partnership with a company called 3D for Medical, is in anatomy. And so you're seeing one of the first full life-size holographic anatomical applications available in the marketplace today. And this is a good example of where we can help institutions save costs. We can help them provide experiences to students that they otherwise wouldn't have. And in some cases, we're actually improving on the teaching and learning over a traditional cadaveric dissection. And so we're very proud of this app. This app is releasing actually this week. And we're getting a lot of use cases in this. The amount of the type of things that you can do and teach in this really are only limited by the imagination of the instructor. That's simulation. Homework. Now this is the thing that we're doing and we're reaching hundreds of thousands and millions of students with, right? We're taking experiences that they would have otherwise not have had or been exposed to and embedding students into situations. That ranges from psychology, it ranges to history, Western civilization, many other topic areas. Here's an example of Chernobyl. Taking a field trip to Chernobyl is just, the Chernobyl site is just not possible. We create very simple 360 interactive experiences that students can access from their browser, they can access from a mobile VR app that we've created, and they can access them through popular platforms like Gear VR and Oculus Go. And I like to end here because this is actually the room where they evacuated from, and there are thousands of gas masks that were discarded 30 years ago and laid strewn around the floor. And seeing this in a VR 360 environment is really impactful for students. So homework is about bringing activities and allowing students to have these activities alone, on their own time, and experiencing them in VR, or really in whatever medium they want to experience. The opposite end of that is collaboration, and this is really where the classroom-based part of this comes in. and where mixed reality is really important. Here's an example of our chemistry app, and this was taken in Australia, at a high school in Australia, and it's showing students building molecules together and learning together. All of our mixed reality apps are about using collaboration in the classroom. They sync together, they allow students to build things together, get tutorials either from each other or from a teacher, and it's very impactful. And this is where we think that the future of immersive really lies. And even in virtual reality apps, you will, if you're going to build a virtual reality app for education, it needs to have some collaborative basis to it. What doesn't work, like I said, is strapping a student into a VR headset and expecting them to learn a subject from A to Z. Really what you need to do is engage students in different ways, to teach them in different ways, through simulation, through self-exploration and homework, and through collaboration. And those are the key areas that we found are impactful. We have efficacy data on the, not only on the students, but also on the impact to the teaching, and what we're focusing on for our 2019 portfolio. So what's next beyond these 4 areas? And really that goes to our R&D efforts. We're working in AI, so you can have impactful interactions with content on your own, have conversations with those holographic patients, where you can explore content fully. We're talking about haptic feedback. We're working with clients now so that we can take the touch and the feel of learning a simulation to a new level. What's next for us is basically what's next for the industry, right? We're all working on these problems now, and we're focusing solely on how we can use them to impact training and education. But we're seeing, we learn from what's going on in the broader AR/VR field. And the excitement of that and the ability to go in and reach students and help teachers is really impactful. So that's a very quick overview of what we're doing. I thought that I'd answer some questions and be happy to have a chat after the talk here as well. Does anyone have any questions about the work we've done? Or yes.
Hi, thank you very much for the talk. You were talking about testing the educational value of different kinds of VR and AR.
Yes.
What were you testing for exactly? So how do you quantify educational value?
So Pearson has a framework, an efficacy framework for testing education. Some of that is short-term. So some of that is motivational. Some of it is being able to track exact learning outcomes, so time to train, engagement with content, and results of exams, that type of thing. The longitudinal aspect of our framework, though, will take many years to fulfill. So has a student, by learning in this way, actually impacted on their overall educational outcomes? Are they achieving better? Are they able to get a better job? Those type of questions, it's too early to tell. I mean, really, it takes years to be able to measure those things. So we're at the early stages, but we are starting to fill out the lower level bits of that framework.
Hi. Do you think that the testing process will begin to change as well now that students will begin learning in AR in a 3D environment? Do you think the testing process will continue to stay 2D as they learn in AR, they do it on paper, or do you think that the testing process will move into spatial?
No, well, we're trying to move it there already. Yeah, I mean, Pearson is also one of the largest testing companies in the world, both in the UK and globally. We have Pearson View Centers all over the world. That the example of the crane simulator, which is a full assessment application, that's being rolled out through our Pearson View Center starting in the UK, and then will be rolled out globally. So you will go as a student and test in VR next year at a Pearson Center. So it is, yes, I think that assessment is changing.
Hello. I represent a students' association from Romania, and one of the main problems that we're confronting with is the fact that they do not want to learn something new but in change, they want to make money. Yeah, it's pretty funny, but do you think that the VR could change this thing? I mean, do you think that it would boost their interests about what they should study?
Yeah, I mean, anecdotally, what we've seen is everywhere in our trials, so in 2016 and 2017, we basically dumped HoloLenses with some content into schools. And at every single school that we dumped it in, from Australia to Canada to the UK, we had students immediately start to develop their own applications in them, some of which are now on the HoloLens store. That was completely unprompted by us. We just gave them the device and showed them some examples of what to do, and we saw students start to immediately build their own use cases. I think that as this technology becomes more ubiquitous and you have access to it in schools and at universities around the world, students will be engaging with it. In fact, many of the greatest apps that we've seen for education purposes are coming out of universities and are not coming from industry. So yes, I think that it is inspiring students. It is tangential sort of to what's going on in our space, meaning we're trying to educate students, but certainly support and learn a lot from what students are doing in the classroom and on their own projects.
Well, you have two. You go first.
Very cool stuff. Curious if you've experimented with AR on smartphones or tablets in education, or you're just focused on some kind of head-mounted device?
Yeah, I tried to show you some of the more interesting ones, but mobile AR is a very interesting use case. What we're finding with that, though, is that the limitations of the technology, both in terms of, if people have issues with the field of view of a Microsoft HoloLens, right? Well, a field of view of a phone is a fraction of a HoloLens, right? So there are limitations in the technology. Where we have had use uptake isn't so much in solving educational problems, but engaging with students. So we do the textbook with a pop-up for primary school students and that type of use case. I'm less convinced in those type of use cases as an actual end in and of itself for education. I think it's sort of an entry-level point. I'm more interested in solving actual problems, and holding a mobile AR tablet up in education isn't so compelling. But holding it up in training, learning how to do something, being walked and guided through an experience, that has definite merit.
Oh, now it's my turn. I was just taking a picture of you. That's a fantastic talk, and I love all the work you're doing. So you mentioned that you're collecting a lot of data on sort of the efficacy of the programs and learning outcomes. Are you sharing that data in the form of white papers, or
Yeah.
Because I'd love to take a look, and if you can share with us where we might be able to find it.
So we do, Pearson shares all of its data when we create our efficacy reports on our products. Like I said, some of that is longitudinal, so we'll be, and our products as an official product launched in May. So it's very early days. I would anticipate by the end of next year or early 2020, we'll actually release our preliminary results. But it'll be many years of tracking and releasing data, and all of that is released on our website.
Great, great. Any other questions? Thank you so much.
No worries, thank you.